Greetings, Synergetics fans. This is a continuation of some explorations that David Koski and I have been doing. Call it the triangular book covers with a triangular page going back and forth. You describe it that way to reinforce that the edges are all the same length except for two, the two being colored differently. The magenta or purple and the green are the only varying edge lengths in this picture. And we've defined two tetrahedra this way, and they have complementary, structure, but also their volumes are identical at all times, even though they're both getting bigger and then shrinking again as the page approaches an extreme. They always have the same volume as each other. And so this is what we would call two complementary tetrahedra. And the point of the video here is to talk about how three tetrahedra, these two and a third one that I'm going to show you pretty soon, are very versatile in letting you build a space-filling matrix or a simplicial complex with any two of them making an octahedron. Together, two of them, they make a half octahedron. And then the remaining tetrahedra fill in the gaps between those octahedra. So that's what we're driving at. Now, what we see here are two pages diametrically opposed. So I changed the code a little bit. I added a second page object. I have it flapping. Basically, it's 180 degrees to the first one. And in rotating it this way, I am showing how that the two complementary tetrahedra, obviously they make an octahedron. And the third tetrahedron I'm going to show you next that has edges in common in terms of lengths is the space-filling complement that you need for this octahedron. And even more than that, you can pair the so-called inadvertent tet, that's what David Koski names it. You can pair it with either complement, or you can pair the complements with each other. And any way you do it, when you make a pair, you get an octahedron, and the last one out, the odd man out, is the tetrahedron. So the tetrahedron in a space-filling matrix, I should say, like the isotropic vector matrix or IVM in synergetics. So now we're going to look at the inadvertent tet. This is the third tetrahedron in the sequence. So you've got the two complementary. Now we take the green and the purple edges from the complementaries, and at the same time we create this third one with those changing lengths. So they're all three being produced together, and it's when you freeze it at any point and get those three that you have this game you can play where any two of them will be a half an octahedra, and the last one, the one you didn't pick, will be the tetrahedron that fills in the space. That's pretty interesting generalization, and I'm pretty interested in modeling it further for you in visual terms. I know I'm kind of pushing your imagination here in just showing you the tetrahedra individually and never showing you the isotropic vector matrix that I'm talking about. That's kind of stayed off camera, but if you've been reading a lot of synergetics, you kind of know what I'm talking about. Thanks for listening, and we'll talk to you again later.